Right, so for the next part of matrices, we're going to consider transformations which happen in 3 dimensions. So you've already seen reflections and rotations and things like that, but we want to extend that to what would happen if you tried doing it in a 3D space rather than just in the plane in a 2D space. In order to help understand that, we need to begin by thinking about a way of describing 3D space. We need a coordinate system that uses 3 numbers. So to help you imagine it, I want you to think about a corner of your house where 3 walls meet. And it's actually quite important that you choose not just any corner, but like the bottom left corner of something. Okay, so in my house, I've got a bottom left corner over here. That's going to be the origin. This point here, we're going to call 0, 0, 0. That's the origin. The x-axis goes along here, and the y-axis goes up here. So far, you could think, well, you already know about an x-axis and a y-axis. X going along the bottom here, y going up, because when you draw graphs and things, that would be here. You draw them here. If you wanted to draw an x squared graph, then you go 0, 0, 1, 1, 2, 4, then 3, 9, and you'd be drawing in this plane here. So the sort of standing up plane that I'm indicating here, where the light is attached, that's where all of your graphs that you know about so far, that's where they exist, in that plane. We call it the XY plane. Confusingly, it has another name, which I'll come on to later. Another name for the XY plane is Z equals 0. But I hope that makes sense in a minute, because there's one more direction you could go in. I said that this is the x-axis down here horizontally, and standing straight up is the y-axis. Well, therefore, coming out the screen towards you, along this wall here, this is the z-axis. I said it was important to choose a bottom left corner, because only when you do that is the positive z-axis coming out the screen towards you. All right, so if this is the positive x, this is the positive y, then coming towards you now, following parallel to this wall, that's the positive z direction. If I went through the wall and into my next door neighbour's house, that's the negative z direction. Negative x is going this way, so from the origin is going that way through that wall, and negative y will be following this y-axis down through the floor. So I hope it's a fairly obvious sort of system. I'll show you a different way of representing that with sort of sticks in a different video. But for the moment, that's how our coordinate system works. I can describe any point in space. So this red ball is supposed to represent a point in space. Now, normally coordinates are given like the point 1, 2, and what that would be is 1 jump in the x direction, 2 jumps in the y direction. So 1, 2 in this 3D system is 1 jump there, 2 jumps there, and I could have different scales. I've decided that 1 is about, it looks like about 50 centimetres. I've decided what 1 is, so I'm about 1 metre off the floor with my 2 jump of 2. So 1 jump to the right and 2 jumps up. That's my point 1, 2. In 3D space, we call this 1, 2, 0, because it's not coming out of the, it's not coming towards us at all. It's still flat on this plane. So this is no longer the point 1, 2. It's 1, 2, 0. If I wanted something like the point 1, 1, 1, that would be from the origin, 1 to the right, 1 up, and then 1 towards you, 1 coming out of the wall. It's very difficult to see any kind of depth on this video, I understand. Maybe I'll do 3, 3, 3, so it gets a bit closer to you. So I've got a jump of 1, 2, 3 in the x direction, 1, 2, 3 in the y direction, and 1, 2, 3 in the z direction. So where I'm holding the ball now, this has coordinates 3, 3, 3. It went 3 along the x-axis, then 3 up the y-axis, then 3 towards you, 3 in the positive z direction. I can represent negative numbers. I can have negative coordinates, but unfortunately they'd either go through the wall this way if I had a negative z direction, or they'd go through the carpet, which I can't represent with this particular ball. All you can see here in the space that I'm standing, everything here has 3 positive coordinates. So I showed you that about here was 3, 3, 3, but like everything that's going to the right and up and towards you, they are the positive directions. So although of course it is possible to have negative coordinates, I can't show you with this ball. I now want to consider vectors. Recall what vectors are. The definition of a vector being something that has both size and direction, magnitude and direction. You can represent vectors with columns, kind of a column vector. So remember when we do translations, you haven't done any with the matrices recently, but you would have done them at GCSE. Suppose I want to move a shape, maybe a triangle or something, I want to move it 1 to the right and 2 up, then I would call that movement of 1 to the right and 2 up, I could represent it with the vector 1 on the top and 2 on the bottom. In the same kind of way, I can still represent vectors with, we call them column vectors when we do that, but now they're going to have 3 coordinates. It's not clear to me whether this is coming out on the video or not, but what I've written here is 0, 1, 1. And what that's telling me is a movement that goes, that doesn't go to the right, so there's no jumps to the right, but then do 1 jump up, and then do 1 jump towards you. So go nothing in the x direction, go up 1 in the y direction, go along 1 in the z direction. And that represents a movement. Right, so this is Alex, my housemate. So at points in this video we'll get closer than 2 meters, but don't worry, we do live together already. Now, I'll just explain to Alex, he hasn't done A-level maths for, what, 5, 6 years, something like that. He did do A-level maths, it was a long time ago.
Oh, longer than that, yeah.
So possibly longer. Well, my apologies, 10 years ago maybe. But he does understand maths, all right? So I'm not going to sort of make it too babyish or anything. Now, Alex, this room represents a coordinate system. The very corner is the point 0, 0, 0. Do you remember 3D coordinates, or shall I flash it out a bit?
Maybe, yeah.
That's fine, okay, fine.
So, X and Y axis, and then there's...
Yeah, absolutely. So this is the x-axis along here, this is the y-axis along here.
Right,
So all the graphs that you normally do live on this plane here, and we don't know about depth early on in GCSE.
No.
But then you sort of say, well, okay, I don't just want to move to the right and up and down, I also want to be able to come out of the page as well. So we're in 3D space right now, and you would represent points in space as things like 3 numbers. I might say the point 1, 1, 1, let's go 1 to the right, 1 up, and then 1 out. Exactly, right? So that's your 3D coordinate situation.
Sure.
But that just represents single points.
Yeah.
Vectors represent a movement from one point to another. I'm showing Alex 0, 1, 1. And recall what that's going to mean is don't do any movement to the right, so don't go along the x-axis. But go 1 up, and then go 1 forwards. Okay, so that's what that's going to represent. So we're going to try to represent 0, 1, 1, but we'll do it with string. So you hold one end, and I'll hold the other end. Might make it fairly short here. Now, we'll go in the direction me towards Alex. So my fingertips are a point in space. It doesn't matter where they start. Alex's fingertips are a different point in 3D space. It doesn't really matter where they are either. If we both take a little step this way, this is exactly the same vector that we just had. It's represented somewhere else in space, but the movement to get from here to here, from my fingertips to Alex's fingertips, is exactly the same as the movement that was required when we were standing over here. The jump from my fingertips to Alex's fingertips is a certain distance to the right, it's nothing up and it's nothing outwards, right? So it doesn't matter where we start. Now remember, what we're trying to represent was 0, 1, 1, from me towards you. I'll edit this so it looks really smooth and good, right? But I'm going to stay still. Can you make it such that from my fingertips to your fingertips is 0, 1, 1? And don't worry about the scale. You can have that being 1 or this being 1. Totally up to you what the scale is.
It would be, so 0 move along, it's going to go up, and it's going to go out 1. So it'd be here, wouldn't it?
And then can we hold it such that the camera can see? And you need to be up as much as you came out. Brilliant,
Yeah.
perfect. So what Alex has said is don't go any distance to the right. He was correct, because had 0 on the top. The one in the middle may go up 1, and the one on the bottom say go forward towards you 1. So brilliant, that's exactly spot on, Alex. Let's do another one. I hope you can read this okay on the. We're now going to try 1, 0, 2. And it'll be, again, from my fingertips to Alex's fingertips. So 1, 0, 2, from me to Alex. 1, 0, 2.
Okay, so 1 will be going back 1.
Good.
And then 0 up, and then 2 out.
Perfect.
Yeah.
Absolutely spot on. The next one, and again, remember the scale's not important. We can decide how big a jump of 1 is. Alex can decide the scale for himself. This one is 5, 5, 5. So I want to, so from my fingertips to Alex's fingertips in that direction, from me to him, what would 5, 5, 5 look like? You can decide the scale, of course.
Yeah, sure. So obviously, say this is 5.
Yeah.
And I'll go 5 here.
Yeah.
And then 5
Yeah.
here.
Perfect. So it's moved in all directions the same amount, and it didn't matter what scale we chose. If you want to just keep that position for the moment, and yeah, that, you can see that on the video. Good. Alex, how would we easily represent -5, -5, -5?
-5, -5. I would be kind of opposite, right? I'd be down there.
Absolutely, we need to swap places.
Yeah.
Okay, so it's the exact same like angle to everything, but remember we were going from me to Alex. So to get from me to -5 is now 5 to the left, 5 down, and 5 not towards you but 5 away from you. So it looks the same when you represent it. If you were drawing lines or something on a page, 5, 5, 5 looks the same as -5, -5, -5, but you draw the arrow the other way.
Cool.
So the last one I want to represent is a mixture, where this time, and again the scale is not important, I'll let Alex choose the scale, 1, -1, 0. Okay, so we'll, from me to Alex, 1, -1, 0. Good luck.
Yeah, sure. So obviously 1 out from
Mhm.
you, and it'd be 1 down, and then not going out anywhere. So yeah.
Brilliant, expert. Well done.
Cool.
Thank you very much for your help.
No worries,
Appreciate that. But hopefully that's clear to you. I might recommend that you grab a brother or sister and you try playing with string, and you try to understand what vectors in 3D are doing. Vectors in 3D aren't any more complicated than vectors in 2D, in as much as they just represent a movement from one point to another, a fixed distance, magnitude, and in a fixed direction. It's just we've got 3 directions to play with now. Hopefully clear on the video, but if not, play with some string. I encourage you to have a go, because they're very hard to draw. You can't easily draw these on paper, because paper is hopelessly 2D, whereas when you're waving string around in a 3D space, you can actually represent it realistically. Okay, best of luck with this.